All right, so this is a review and summary of lesson 7 and 8 in our unit 3. So some of the key things I wanted to point out is the first things we looked at were measures of center. The two that we work with are mean and median. So as a reminder on how to find those, for the mean, this is mean, it makes you do all the work. We are going to add up all of the numbers, and then we are going to divide them by however many numbers we actually have in the system. So in this case, I would add all of these up and divide it by 6. So if I were to do that, I add up 15 plus 25 plus 15 plus 23 plus 26 plus 31. I get 135, and I need to divide it by 6 because there are 6 terms in this situation. And we end up with 22.5. Now, they did already tell that for us, but just as a reminder. To find the median is middle. So to do this, we need to actually first put these in order from least to greatest. So 15, 15, 23, 25, 26, and 31. From here, we are going to whittle it down into the middle. So boom, 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 boom. Now at this point, if I am left with 2 numbers in the middle, we can see that I've crossed off the same amount on both sides. We're then going to figure out what number comes exactly in between 23 and 25. In this case, we know that it's going to be 24, but if I didn't know for sure, I can add the 2 numbers up together and then divide by 2. We're essentially finding the average between these 2 numbers, which in this case, we would get 48 divided by 2, which is 24. If I had an odd number of terms, I would probably end up with a single number for our median. But depends on if you get 2 or 1. When it comes to finding the mean and median, there's a couple differences that we want to utilize. So for measures of center, kind of showing us that central data, the mean, at least in cases like Drew, is at 21 versus his median at 25. In terms of which would represent like his typical scores in this game that we played, the median would be a better choice. One, because it kind of shows where most of his numbers are, but also because he has an outlier here. This outlier pulls this mean farther away from the median. So a big thing that I would like you to remember, the outliers pull on the mean. But they do not alter the median. So in this case, if you have an outlier or you're unsure, use the median rather than the mean. The second part we looked at was a measure of spread, specifically something called a standard deviation. In this first one here, we were looking at something that has a large standard deviation. What this means is that the data is really spread out. As we can see, we got fish of different sizes, hence why our standard deviation is so large. So, roughly approximate this one. If you have a large standard deviation, the data is really spread out and really varied. Versus, if we have this one here, we've got a really small standard deviation of just 0.3, and we look at the size of these, they're really close to the same size. So a smaller number means that they are closer together. A lot of them are around the same price. There's not as much variation. Versus a larger one, the data is going to be very well spread out. They're not going to be as similar to each other. So we can utilize that idea as we order these from the smallest standard deviation to the largest standard deviation. It does say use a calculator to help with your thinking, but we can actually do this one without a calculator. So first, looking at this, we've got some that are range. We've got a couple varieties here. Looks like our range here would be 7. We've got a little variety here. with that pull from one side to the other. And then finally we have from 8, 9, 9, 9, 9, 10, 11. These ones are pretty well close to each other, excluding this 4. This one is probably going to be the smallest standard deviation, just because it is fairly well similar to each other. The next one I would say is probably this top one. And this is because even though it does have a wide range, there are a lot that are actually pretty close to each other. We've got a lot of repeats. The only thing is with this last one is that it is such a range from 1 to 10, so this is probably going to be our largest. Now, in terms of when it's using the calculator to help, this is a Desmos calculator. If you have access to an online platform with this, you can use this to check your work. Most of the time we will not have this. We will not be calculating standard deviation by hand, at least not in this class. For now, I want you to just be able to kind of look at those numbers, see how close or spread out they are to make a generalized statement.